Hi, I'm answering your question through the video. I particularly use a video because there's graphics that needs to be made, and I cannot do it just on the answering platform, so I opt to use a video. But anyway, your question exactly is that there's a boy pulling a box of with a force of 110 Newton, right here, and he's pulling it up an incline of 28 degrees. Now, the weight of the box, the mass of the box is given to you as 48 kilogram. Now, and the question is asking is whether this pulling force will cause work. Now, for any force to cause work, the box will have to move up a certain distance, because work is equal to the force times distance cosine this angle here, cosine 28, if it's on an incline. Okay, so for us to see if we have work, first of all, we have to see if that force is going to move the box up and which direction the force is going to be. Okay, so in this case, you got this boy pulling at 110 Newton. His mass is the box mass is 48 kilogram. Therefore, we can determine the weight of the box, which is W, equal to the mass times acceleration due to gravity, mg. That's equal to 48 kilogram times 9.8 meter per second squared. Bear with me a little bit here with this graphic. It's kind of hard. Meter per second squared. And if you do the calculation, you will get 48 times 9.8. You're going to get 470.4. I'll call it 470 Newton. 1 Newton equals 1 kilogram meter per second squared. Okay, so now so what are the forces exerted on the box? You got this pulling force with the boy, 110 Newton. You got this force here, which is the normal force, actually. That normal force is always perpendicular to the plane of action. Well, plane of action is at the incline, so that force is going to always be perpendicular to that plane of action here, which is that incline. Okay, so the normal force is what? The weight cosine this angle. Now this angle is the interior angle of this, and this angle and this angle are the same, so it's 28 degrees, and is equal to 470 Newton cosine 28 degrees. And that'll give you 470 cosine 28, 415 Newton. So now that weight also has a horizontal component, which actually parallel to the incline, and that's a force that we actually need to consider to see if the box moves or not. That force here, I call that just force F, is equal to 470 Newton sine 28 degrees. Sine 28 degrees. So F is going to equal to 470 sine 28, 221 Newton. Okay. Now, what benefit is this normal force? Would that normal force cause a movement of the box? It would not, but the normal force will determine the force of friction, which is actually opposite to the line of action of the force pulling up. So there's also a force of friction here, which is opposite and parallel. That force of friction is here. It's parallel. This force and this force are parallel to each other. And that force of friction is equal to mu n, where mu is given to you as a coefficient of friction. It's 0.32 times n. N is 415 Newton. And that will give you, my calculations, 133 Newton. Okay? So, in order for us to see if this force of 110 Newton is going to cause work, okay, we said that the 110 Newton will have to move the box at least a certain distance, because work is a force times distance, and on an incline, it's cosine the incline, cosine the angle of the incline. So we use the general law, sum of the forces about the object is equal to the mass times the acceleration. Simple as that. So sum of the forces, you've got, let's consider that the forces up are positive. So you got a positive up force, which is 110 Newton. And there's two forces pulling down, which is that F force here. We said it was 321 Newton. And a force of 133 Newton, which is a force of friction, which is minus 133 Newton. So the sum of the forces, this is Newton, is going to be 110 minus 321 minus 133. Oh, wait a minute. Let me see. 470 sine 28. Oh, sorry. This is not 321. This is 221. So correct this. That 221. Okay. So this is actually 221. 221. So 110 minus 221 minus 133 is minus 244 Newton. What is that telling me? Or telling us? That telling us that the force resultant of the forces along the incline is actually in the downward direction, which means that this force here that this boy is pulling with isn't enough to move the box. Actually, the box is moving downward. Therefore, the answer to your question, whether the force that the boy is pulling with is going to cause work, is no. It will not cause work. And again, I say because the sum of the forces turned out to be negative, which means that it's pulling down instead of pulling up. Therefore, the work is being done will be done by the minus 244 Newton, which is pulling down, and the 110 Newton that the boy is pulling with does not cause any work. Okay, so this is your answer. And just want to add one thing here also. We know the mass of the object, but we do not know what the acceleration is. Now, just to, it's not part of this problem, but I just want to add this for you to just basically get an insight. The acceleration is zero if the velocity is being constant. Now, we do not know what the velocity is doing here. We have no distance. We cannot compute that. But let's just say that he says in the problem statement, the box is moving with constant velocity. Therefore, immediately, A is zero, and this whole term will be zero. Okay? So, but if he doesn't say anything, which is not in this statement or problem statement, then if the velocity is not constant, therefore there's a consideration for acceleration. But like I said, this is not part of your problem, but just wanted to bring this as an insight. And the final answer is that no, the force that the boy is pulling with up is not going to cause work.